This is the Smart Buildings Academy podcast with Phil Zito, episode 355. Hey folks, Phil Zito here, and welcome to episode 355 of the Smart Buildings Academy podcast. In this episode, we are going to be responding to a comment that was on our YouTube channel about can you do the same thing you did for BACnet, which was we did a BACnet 101 podcast on Monday of this week. And he said, can you do something similar, but for plans and specs, like walk through them, kind of talk through what they are, how do you analyze them, kind of do, a 101 level review of plan and spec documents. So without further ado, on today's podcast, we are going to be diving into plan and spec documents. We're going to talk about how do we review them, what do we look for, what are the different parts and pieces of them, how are they structured. So we're going to have some fun. As always, everything will be available at podcast.smartbuildingsacademy.com/355. Once again, that is podcast.smartbuildingsacademy.com/355. If you see me looking away from the camera quite a bit in this episode, it's because I am reading through documents that are on my desktop as I go and take you through this. All right, so speaking of desktops, let's show the desktop on the screen. And the first thing we're going to start off with is we're going to do a high-level kind of discussion of specs, and we're going to talk about mechanical plans. Now, specs and mechanical plans are developed post-tender. So tender is the funding of the job, and then you select your contractors, your general, your engineer, etc. And I'm going to super high level this, folks. So what happens is you create documentation based on the owner's intent of whatever this project is. So typically start with a kind of site drawing, a vision, which will turn into architectural drawings, which then will turn into the mechanical, electrical, plumbing drawings. Now, drawings typically go through 3 phases before they're released as construction documents, or released to construction. So you will have your schematic design, you'll have design development phase, and then you'll have construction design, right? So SD, DD, CD. And what happens is you move through these and you may hear 50% DD. That may be a term you hear. That means the drawings are 50% design development phase. So how I like to, and this is kind of a rough description of drawings and specs, but how I like to explain this is that, the schematic design is laying out the skeleton. The design, the development design is the muscles, the circulatory system, etc. And then the construction design is putting on the skin. To give you a better example of this is if you've ever worked on building your own home, or you've been involved in maybe building your own home, you start off working, if it's not a spec home, you start off working with an architect, you create your vision, then you get the schematic design, which is the general layout, what's the orientation of your house, etc. And then you move on to design development, which you start to lay out floor plans. And then construction design gets into the specific details of the actual layout, like where's the HVAC ducting, where's the lighting, etc. Where's all this stuff go so that it can be released to construction and built. Now, that is also true of specifications. So whereas the drawings provide a visual representation, and we can kind of see that right here, they provide a visual representation of where mechanical, electrical, and plumbing systems go. The specification provides the details as to the requirements, both from an execution perspective as well as from a product selection perspective and a phased implementation perspective. This will all make a lot more sense as we go through these. So first things first, we've got a mechanical plan on here. Now, what you'll typically see, we're going to start from, front to back, and we're going to start with the front page of mechanical. So what you'll typically see is a symbol listing as well as an abbreviation listing. This is where, it'll tell you, hey, these are what these symbols mean. These are the representations of the symbols. We can see them all right here. I know I'm moving pretty quick, but you can see kind of what the symbols mean. And then we can see any abbreviations, what they mean. We'll also have our general notes that will discuss kind of any general notes related to the mechanical systems that we may need to know. I'll come back to that in a second. How these pages are going to be laid out is we're going to have a page right here. So it's going to be mechanical 01. Sometimes there is a actual, what's the lack of the better, what's the word? Oh my gosh, it's just slipping my mind. Table of contents essentially, but there's a different word for it. And it'll list out what the pages are. You can see we'll move into the 100s, right? And then we'll move into the 200s, which are typically our floor plans. And then we will move into the 400s, which are typically going to be mechanical details, as well as our schedules. And then we'll start to move into our flow diagrams, right? Which are going to be our 5 series right here. Okay. Now let's take a second and look at specs, and then we'll dive deep into each one of these documents. Let me just see if anybody has any questions thus far. No, we are good. So specification, this is based on CSI master format. You can tell this is the more current spec standard because we're Div 23, Division 23, Section 0900. Now what we see here is a section called General. This is typically going to give a narrative of, what systems are included, basis of design, related sections, etc. We're going to go through each one of these in a much deeper way in just a second. Then we will eventually get to the section 2 right there, which is products and or materials. So this is typically called products and or materials. And what this will list out is basically very detailed, well, hopefully very detailed explanation of materials that go in the project. This will be everything from communication trunk standards, controller type standards, panel standards. And then once you move from that, let's get through all the BACnet stuff here. You will actually start to transition out of the controllers into the I/O, which they call auxiliary control devices. This is where we will find our standards around valve types, damper types, I/O, inputs and outputs, sensor types, etc. This is something, just segue real quick, that is really important. I've seen people buy 1,000+ room sensors only to have to find another job for them because the spec'd a specific color to the room sensors, and that was missed. And they bought white, and I think it was like off-white beige that they had to be. And because of that, they actually had to go and use those sensors on a separate job. So there's something to be cognizant of. Then eventually we'll get to part 3, which is typically called execution. This will talk about the execution of the project. So whereas general will typically get into submittal and initiation, part 3 will typically talk about execution. So how do we coordinate? How do we validate? And then how do we ensure proper operation of the system, sequence of operations? And then how do we go and close out the project? So we'll see all of this kind of come together real quick. I'm going to take a sip of water real quick, though. Alrighty. So let's start with mechanical plans. And as always, if you have any questions whatsoever, just feel free to talk about that. I see someone brought up something about Div 25. I'll give my thoughts on Div 25 if we have time later in the episode. It's a world I lived in quite a bit in my previous employment. So depending on time, we'll go through that. All right, as I mentioned, table of contents, Mechanical general notes, abbreviations. Not much here. I mean, once you've looked at enough drawings, you start to recognize, oh, that's a valve, that's a control valve, et cetera, et cetera. The area I like to really focus in on is the general notes, because notes can sometimes conflict with spec expectations, and they can also go and kind of get you in and or out. See, one thing I want you to think of is for every negative that I'm going to discuss today, there is also an opposite positive. So for example, Div 23 mechanical contractor shall coordinate with electrical contractor prior to actual installation of temperature and humidity and carbon dioxide sensor. All right, so why would this matter, and where's this coordination come in play? Well, picture this. So building's being built, slab gets poured, stubs are put in, and walls start getting put up. And then, just then, you decide to get with your electrical sub, have them go out and start putting in the sensors. Well, if you had actually coordinated with the electrical contractor, you might have been able to get some stub ups in the mechanical rooms and in the slab. You may have been able to coordinate some potential stubs for your electrical that are in your walls, etc. I mean, it really just depends what's in scope for people. But this coordination is going to save you relocation. And quite honestly, I would say that Div 23, it's not always the mechanical. It can sometimes be building automation. And so I would coordinate not only with electrical, but would probably coordinate with mechanical as well as to accurate locations. Because we've all been there where something is being built and then all of a sudden an electrical panel is placed right where your thermostat's supposed to be and you've got to relocate. Well, let's see if there's anything else that pops out. No, I mean, nothing really that pops out. Testing and balancing. Contractor shall provide all necessary testing and balancing for the project. So that's something I'd want to kind of understand. Granted, this says this is the mechanical plans, so I would assume that means the mechanical. All right, so we get into our general plan right here. We look at see if there's some stuff that has anything to do with us. I mean, coordinate with electrical contractor for data connection to the chiller BMS interface. That's a pretty important one, right? We've all been there where someone didn't catch the BACnet card, and so a unit was provided without a BACnet card. In this job, there's an existing chiller, and so we need to coordinate to run some electrical wiring out to this. So that would be something that we would want to be aware of, right? So these, at this point, I'm just going through notes. So when I look at a plan, I'm sorry. Oh, Siri. Let me take off my my watch. I just hit the button. I move my hands so much, and yeah, my watch hit something there. All right. So whenever I look at this, the first thing I do is I go through all of the notes, and I make notes of the notes. Anything that potentially could involve me, data to the chiller, something about automatic isolation valves, right? This information would be important to know, especially if I'm providing valves. Then, and I'm not going to take you through every note in this job because that would take a long time. Then once I've gone through the notes, I like to go to my equipment schedule. And with my equipment schedule, I start to build a rough bill of materials. So I will go and I see that question in there. I'll get to that in just a second. I start to build out a rough bill of materials. I start to kind of understand, all right, this is what I have on the job. So right here, I'm seeing I got variable air volume boxes with electric heat. It's SCR, so silicone controlled rectifier, which means, it's 0 to 10 signal. And also some other notes, right? Controls shall be provided so I can offset some cost by having the terminal unit manufacturer mount my controllers, as well as providing the transformer. So I can start to see some information. I start to make notes of all of this, right? Once I've made notes of this and I've built out a list of materials and a list of systems, then I go, excuse me, and I go to my floor plan and I start to figure out like, okay, how is this going to kind of lay out? All right, so I've got my VAV boxes, kind of figure out how I'm going to lay them out. I try to find my general mechanical room. And I also try to see, oh, there's something right there that I'm going to potentially need to control. So I'm going to go and say, oh, well, maybe I'll control this right here with VAV A19's controller. So I'll expand that controller. Now, right now, I'm just trying to get a snapshot. So if I'm in pre-sales and I'm estimating, which was the question, like how long should the estimator, let me see what that says. What does that say? How long should the project estimator to read and understand specs and drawings? It depends, right? It's not a cookie cutter answer. Like this one right here would probably take me an hour or two to go through just because there's so many related sections in the spec. And we'll talk more about that in just a bit. But it's not a matter of time, although time is important. It's a matter of accuracy. And what I mean by that is I would rather you spend an extra 4 hours being accurate and win a project because you realize, oh, you know what? These are all backnet cards on all these air handlers, and thus I don't need to provide controllers. Then you just rush through it and miss something like that. Some of the common misses that I see are people missing who includes mechanical materials. Like sometimes the valves and actuators are included by others, installed by controls contractor, or included by controls contractor, installed by others. That's something you need to catch. Integrations are a big thing to catch, as well as being able to use controllers for other systems that may be nearby. Like right here, right? We have a mechanical plan with a fan coil unit, exhaust fan, and then we have our air handling unit right here. And as we actually go in here and we look at this, we see our mechanical plan and we see a note right here, note 10. See that square box right here, note 10? So if I go over to note 10, I'll notice approximate location of DDC panel to be mounted. So that tells me if I were to read more of the notes, I could find out that AHU VFDs to be mounted and installed by electrical contractor. So we know that the electrical is actually mounting and installing these. So we're going to need to coordinate with them. These are all things I've got to start thinking through. Mechanical plans aren't terribly difficult to digest. There is some things that are unique to this plan that I don't see in a lot of plans. And forgive me if I'm scrolling fast and making you nauseous. I apologize for that. They do a pretty good detailed drawing of the BAS network. I don't typically see this, but they actually do in this drawing, which is kind of nice, right? We see our layout of our drawing. The one thing I will caution you on is if you do happen to see, right, a controls schematic, or you see a sequence on a mechanical drawing and you see a controls one line. This is called a one line because if you draw it right, it's one line. And then you have your control devices. This actually calls out like, hey, there's an AO. Hey, there's AIs. Hey, there's BOs. This is still something that I would be careful of because as you start to go and get the equipment submittals and you read through the specification, things may actually be a little different. This one actually, to that point, has a different sequence for this air handler, this mixed air single path air handler. They have a different sequence here than they do actually in the specification. If we go and we read the specification, there's minor differences in how this spec reads out versus how this reads out. And that would lead you to a request for information, request for clarification to go and figure out which one of these takes precedence. So these are all things that I look at when I look at a mechanical. I'll give you all a couple seconds to ask questions as I get ready to move into the specification. But, you know, as the person from YouTube asked, I don't have a hard set rule on time. I have a hard set rule on accuracy. I have to be able to honestly ask myself, if someone set this set of drawings aside after I reviewed it, could I legitimately tell them the systems that are there and who is providing the parts and pieces for the systems, and if there are any unique integrations? If I can, after looking at the drawings, answer those questions and answer them accurately, then I know I did a good job. And that actually will pay more than trying to slim a day off your time. Because yes, maybe you'll get through more estimates. And this is kind of chicken versus the egg, right? Do you want to have more accurate estimates, thus you can be at a lower cost and you can win more jobs? Or do you want to go and be getting more estimates out the door, but they may not be accurate and they either may not be winning you jobs, or if they do win you jobs, they may be costing your company margin due to slippage and missed things. It's a balance, right? And it's something that just comes with time, unfortunately. Let's go into the spec and let's talk through this. So I'm going to spend a bit of time here. I'm going to try to make this enjoyable and not boring. I'm not going to read from the documents. So give me some grace here. Hopefully it comes through. Let's talk through this. So part 1, general, right? This is going to say some really obvious stuff. We're going to give a building automation system. Oh, really? That's surprising. We're going to control with DDC. Okay, great. BMS contractor shall be responsible for all electric work associated with a BMS. So that one should be like, right off the bat, you should wonder, okay, I see this, but then I also see that the electrical sub is responsible for VFDs. So you're starting to see the conflict there. This is an area where you'd have to ask yourself, do I RFI this? Do I just accept that in common sense land, this means obviously wiring up my controllers, wiring up my trunk, wiring up my IO? Or do you go and actually clarify this more? It depends on the customer. When I'm doing government work, school work, stuff like that, where they have a very heavy hand and they have ability to really come after you if you get something wrong, I tend to like to be clear on everything. If I'm doing more commercial work and, you know, I know that things are going to, you know, this person is probably just wants a system that works, then I know, hey, if it says all electrical work, I can reasonably assume that it means IO field controllers. Your general rule of thumb for this is this applies to the information in this portion of the spec. That's typically. Provide open communication system with multiple vendors. Okay, that, yeah, sure. BACnet, okay. OPC, this is a little interesting. Why do we need OPC? Do they have some form of SCADA system? OPC is kind of more of a SCADA-ish controls protocol, so I'd be interested in that. I'm going to kind of skip down here and move into, all right, provide hardware, software, and wiring to communicate with each of the systems listed below. This is kind of my first red flag here that I really want to understand. I'm going to take a sip of water. Hi, Abe. I see Abe said hi in chat, so I'll say hi to you. Let's continue along. Computer room, air conditioning, lighting control system. All right, so typically the first thing I do when I see any form of integration is I'm going to look for related sections. Okay, related sections. I don't see anything about lighting or crack units. Well, I guess you could argue central HVAC would be crack units, or maybe decentralized H. Yeah, products integrated to, but not installed lighting control. So I want to understand how am I supposed to integrate with this lighting system? Is this something where, remember, there's 3 types of integration, right? Those are physical, that's hardwire, programmatic, and protocol. Well, so physical, protocol, programmatic. Primarily, most of you are going to be doing protocol integration to lighting systems, backnet chillers, etc. You're going to be doing physical to like fire alarm, things like that. And programmatic is going to be to like weather stations, scheduling systems, etc. All right. So moving right along, we have some things we just want to red flag here that we have to integrate to cracks is mostly like a Liebert site link or something like that, or whoever they're called nowadays now that they got bought. Lighting control system. This is typically going to be like a backnet integration, something like that. All right. We see that we have a DDC system, right? Primary DDC panel. This is where I was talking about where panels can combine. So this is kind of right here, right? We're seeing this. Shall be acceptable. We're going to combine these pieces together into a single panel. So they just gave us the approval to do that. And some miscellaneous monitoring, right? Automatic transfer switch, leak detection, temperature, lighting. I don't like that this has kind of got the etc. in here. The risk adverse side of me likes to have stuff pretty well lined out. But I also realize that this is one of those things that, it just kind of, you have to accept. Let me look at questions real quick. When I'm making a rough bill of materials, do you mean to write it down? I put everything into an Excel sheet. I've covered that, I believe, in other episodes. I have an Excel sheet that I use that's my scope of work document, and I build out a tab for each system, and that's where I build out my bill of materials, and I also add my notes. I have a checklist process that I go through. So hope that helps. Let me check, see if we got any questions anywhere else. Looking good. Okay, cool. Let's keep moving along. All right, so we did that. We got some ASCs. That's a backnet term, BTL for application-specific controllers. That's going to be our CAV, FPB, or fan power VAV, and VAV. That's going to be important later in this because we're going to see that it's going to call for backnet IP controls, but then it's going to call for a secondary network with ASCs. And those backnet IP controls are going to be AACs. So we're going to see that for like our air handling unit. And then we're going to see that these more terminal units are going to be ASCs, which are backnet MSTP controllers. And yeah. Abe, I'll hit you up. I'll look up your information. I'll contact you. Alrighty. General product description. So this is just going to go through, all right, some basic stuff. I'm not going to read all this to you. It's pretty straightforward, common sense stuff. Products furnished but not installed. Here's that wording that I talked about that we also see in mechanical drawings, right? Furnished but not installed, meaning that we are furnishing, but we're not necessarily installing. Now, where you have to be careful, and this bites some people in the ass sometimes, is they go and they say, oh, I'm furnishing this, which means I am providing it. I'm including the cost in my estimate. But then they skip over the related section that says, oh, by the way, you're also installing it. So they assume when they read this, they don't have to carry the install cost. But because they didn't look at the related section that said, oh, hey, you've got this related cost, because of that, they end up getting bitten in the butt. So you can typically assume most of this is installed by the mechanical and the plumbing. Airflow stations, they're hit or miss. Pressure sensors, they're hit or miss. Whether you have to install that. Terminal unit controls, etc. Then we see installed but not furnished. This is something that tends to be a little safer, but is also at risk of you going and being held liable for, oh, hey, you're installing this, but you also have to provide it. Products integrated to, you're usually pretty safe on this, except for things like variable frequency drives, or if it were to say like flow sensors, etc. Lighting control, you're almost never going to carry. You're just going to integrate with. I will take a brief moment to talk about integration. Very brief, I promise. Integration is something that you want to be cognizant of because the lighting manufacturer or, the access controller, whoever, may think that they're the lead in the sequence. You may think you're the lead of the sequence. And then you have what are called competing leads. That's where, the building automation system schedules the lighting on, but then the lighting system schedules the lighting on, and they conflict, and you get this kind of like Christmas tree effect where, the lights are on, the lights are off, they're on, they're off. And you just need to be cognizant of that. That's whenever I see integration to another system, I want to know who is going to be the lead system. All right, just checking questions real quick. We're still good. All right, cool. Let's continue. I already talked about related sections. Approved system contractors. We see this one, Siemens. This is where you would submit, if you really wanted this work, you would submit a like for like. Oh my gosh, why did the term just slip my brain? A alternate like for like. This would not be an add alternate. It would be, well, actually it would be an add alternate. My bad. You would do an add alternate for your control system. It never hurts to submit an add alternate, especially if it's a publicly procured system. They tend to take that. So, just because you see someone as the, standard, do not hesitate to do an add alternate. And also we'll maybe get to deductive alternates a little bit later in this episode. Quality assurance. I mean, basic stuff, right? People need to have a service organization, list of 10 projects, This is standard stuff that gets put in to try to exclude the smaller businesses. You can meet it. It's not too terribly difficult if you've been in business for a couple years. Some standard stuff around UL categories, some standard stuff around ISO, some standard stuff around codes. Now we get to submittals. So this is the first opportunity for you to start revenuing business. And I've talked about this a lot in our project management podcasts and courses, where you need to think of your project as its own profit and loss center, its own P&L. And your goal is to get that project cash flow positive as quick as possible. So you're drawing on the cash revenue from the project and not from the business, because then that frees the business's cash up in order to allow it to reinvest in marketing and sales efforts and growth efforts. Additionally, if you're working for a large corporation and you're a branch office, oftentimes there's an interest charge on any cash that's provided to the branch office. So you want to try to work off your own internal cash as much as possible. I'm going to see if there's any more questions coming in. All right, cool. If you see my cursor moving over to my other screen, it's because I'm trying to see if there's questions. Well, submittals, as I said, they're the first opportunity for you to go and make money, because once you submit, you can bill out typically. This is, percent of completion, typically 10, 20% on the project. So you can bill out with this, right? I see your question in chat. I'll get to it in just a second. So I like to pay specific attention to what is the order that things need to be in. What documents do I need to provide? What are they expecting to see? And then what format does it need to be in? Does it need to be in electrical? Electrical. Oh my God. Does it need to be in 11 by 17? Does it need to be in 36 by 24? Does it need to be electronic, etc.? I've seen submittals rejected for stupid stuff like, I wanted it 1117 landscape and you did 1117 different layout. So don't get your submittals rejected because you don't read stuff and understand the basic of basic. Get your submittals rejected for at least something that is difficult. Then it gets into, once it gets through the submittal, it talks about demonstration, talks about what you're going to do with your demonstration. And then it talks about your as-built and your project documents, right? Record documents, like, see, there it is, electronic format and 11 by 17. Please don't get your final 10% on the project held up because you don't submit as-builts the proper way. Like I said, we'll get to the question in chat in just a second. Talks about testing and commissioning reports, O&M manuals, all that fun stuff, right? We'll talk about warranty in just a second. I'm going to see this. What do you do if you see specs that have DDC points list? I'm reading a spec with a ton of points list and it's great. So therein lies the question. Is it a representative points list or is it a standard? So like I refer a lot of people to the Northwestern University Building Automation Standard. I think it's one of the better ones out there. It's grown a lot over the years. It's really nice. They get into points list, point naming, graphic standards, etc. I love that. I think it makes the contractor's job easier, especially if you do business with them repeatedly, because then you can go and establish standard programs, standard graphics, and it makes it easier for the operator. So you need to understand the intent behind the points list. Is it a representative points list or is it a standards points list? And that's what I would ask. If it's a standards points list, then you definitely want to adhere to that. If it's a representative points list, you then can take two schools of thought. If this representative point list, you're maybe on a design build job, and this is during the SD or the DD phase, then realize that's representative. And as the equipment changes in the CD phase, those points lists may change. If this is 100% CDs, then you very well should accept that that is probably the points that are going to be available. I do want to point out that if a sequence and spec requires like crazy trending or crazy alarming, like alarming on every point for a VAV box, and you realize that it's a school district and, you know, a third of the year it's not going to be occupied, definitely go and account for that, at least in an RFI. So that, you know, summer comes along, you're not getting called out on warranty for all our VAV boxes are in alarm. Well, of course they're in alarm because you have an alarm based on temperature and nothing's occupied and you don't have that alarm linked to occupancy. So, you know, try to protect yourself from the nuisance warranty calls. All right. Speaking of warranty, that was not intentional, but this talks about warranty. It talks about your response. So, you know, you can start to figure out how much warranty costs do I want to go in and, you know, what can I do here? Let me just check for any more questions. Okay, we're looking good. Let's keep moving. Products. All right. I have a love-hate relationship with products. I love that products is included. And it makes my job easier as an estimator and a designer to be able to look at the products and go, yep, that's going to be an Onicon dual turbine flow meter. Or, yep, that's going to be a Cetra adjustable airflow meter. On the flip side, and we'll see this in this spec, you can get some products requirements that are a little bit ridiculous. And we'll see that when we get towards the IO portion of the spec. But suffice to say, most of the time, products will list out materials. You note that it says spare parts should be available. So basically, they're saying, hey, don't use brand new stuff because it's not a test site, but also don't use stuff that's end of lifing in 2 months. This is not such a big deal on like commercial or schoolwork that is going to be executed in a very compressed time frame. But if you're working on like a master plan response, maybe for an airport or something like Hudson Yards, you want to consider that your design and your spec and your submission may not actually be implemented for 18 months. And so, you know, that's something you need to take into account is product lifecycle. But most folks aren't going to run into that. Communication, this just lists out, hey, how are we going to communicate? This one talks about a bunch of IP stuff. It's basically saying you need an IP network for the supervisory device and your central plant and air handler controllers. That's called the primary network. Those of you who work with Siemens, you're going to recognize the language in here. And then you'll see your secondary network, which is ASC. And here's where the non-observant person could get really hosed. Now, granted, this is flat spec Siemens, so I wouldn't expect them to mess up considering it's a flat spec. But imagine this being an open spec and multiple bidders and multiple vendors on this, and they don't catch that there's a secondary network for the ASCs, application specific controllers. That's your terminal units. Remember, we saw that in section 1. And they don't catch that it's RS-485. What's RS-485? If you listened on Monday, you know that that is the wiring and communication standard on which BACnet, MSTP, and Modbus RTU are built. This is BACnet MSTP. All right. You also know that they're doing a big no-no in here. Big no-no. Not good. Maximum 96 TECs on an individual secondary network. I know that you can do it, but just because you can doesn't mean you should. You know if you've listened to me for any amount of time, and I know I'm preachy, if you follow the RS-485 standard, 64 devices, 32 on each segment, that you're not going to get in trouble. As soon as you go above 64, you risk data issues. All right, building controller software. I mean, this is all just listing out BACnet stuff, bibs and BTL and BACnet profiles. We talked about this on Monday's episode 354. If you didn't catch it, go back. I'm not going to spend a lot of time on BACnet. All right, let's scroll through all these shenanigans. Just basically, it's like a product cut sheet, essentially, until we get to I/O. Let's keep going. Bunch of bibs. Oh, okay. I said I wouldn't talk about BACnet, but I'm just going to talk about it just a little bit. Just let me a little bit. See that A and B? So, right, we have initiate. So client, execute, server. That's what I was talking about Monday when I said you have devices that can either be a client and or be a server. So they can be both. And clients initiate the services and servers execute the services. All right, let's keep going. All right, through this, ASCs, through this. Let's get to IOs. Let me just check LinkedIn for questions. Okay, are we seeing anything come through here? Oh yeah, there we go. Now the questions are coming in. See, the thing is, the software I use gives me questions for YouTube and for Facebook. It does not give me questions for LinkedIn, so I have to switch screens. As a salesperson, I found general conditions to be a source of grief or your best friend. Yeah, great catch there, Scott. I didn't talk about general conditions, but absolutely right, because general conditions, which are set as the general conditions of the contract, those can override even your scope letters. So I've seen scope letters that say we're only going to do normal business hour work. And then the general conditions, which you're signing a contract, say that you're going to man it whenever it's needed. And all of a sudden you didn't estimate for 24/7 work, but you're expected to do that. General conditions also cover things like liquidated damages, which, even in some cases, delays out of your control, you still need to execute. So, hey, it rained for a month and they didn't get power up because they couldn't pour the slab. Well, that doesn't matter. You still need to be able to hit the schedule so they can get the certificate of occupancy. So those are things that you should be really cognizant of. Thanks for bringing that up. Equivalent. Yeah, thanks, Eric. I appreciate it. That's the thing about doing stuff live and not recording it is you have to think on your feet. And sometimes I mix up words. I have a bad habit of doing that sometimes. All right, let's continue along. So, IOs. Alrighty, this talks about the inputs and outputs of the controller, but I actually want the IO devices. And this is where things get a little bit squirrely. We're going to skip over valves and dampers, I want to get into here. All right, temperature sensors. All temp sensors should use platinum RTDs only, okay? And 4 to 20 milliamp loop. All right, so if you've been through my course on design and hardware selection, you've seen this before because this is the spec we use in that course because it provides a very good example of if you don't catch this and you assume reasonably that you're working with a school and schools are usually cost sensitive, and this isn't a lab environment, this isn't a place with a lot of EMF, so a lot of electrical interference, there's no logical reason for platinum RTDs and 4 to 20 signals. That adds probably $30 to $40 per sensor. So this is something that you say to yourself, if I've got 1,000 sensors here and I can go and potentially RFI this with an alternate of a nickel resistive, 1K or 10K type 2 sensor, whatever, like 1K RTD, 10K type 2 thermistor. If you can submit that and get it approved, you've just dropped your material cost by $30,000, which when you apply margin on top of it, that may be, $35,000, $40,000. You've just made yourself much more cost competitive. And so it's important to read through these, not just from a selection perspective, right? Not just saying, oh, I'm going to go and I'm going to select my materials. It's also from a cost perspective and a strategy perspective. So that's what I read through, right? I start to just understand. And over time, you'll start to know like, okay, this is dew point. This may be like an ACI dew point sensor, whoever, right? And then finally, once we get through here, so at this point, right, we built out our mechanical list. We've built out our list of equipment. We've started to build out our BOM. So we've said, okay, we have zone temp, we have discharge temp, etc. I need to take a sip of water real quick. 1 second. It's now at this point that we go and say, all right, now we can pick the specific devices. We can start to figure out what exactly do we need with our devices. And I'll look at things like an airflow pressure switch, right? So this is a differential pressure switch, diaphragm type. Switches shall be single pole, double throw, used for fan status. So I could probably use the DP series of the Cleveland controls instead of the AFS series, because the AFS series are going to be, is it adjustable? Crap. Yeah, I think these have to be adjustable. So I may have to use the AFS series. So yeah, these are things you can figure out because the difference between the DP series and the AFS series of the Cleveland control can be like $20 a sensor. So if you have a lot of these, that can add up. So it's these little nuances, right? Let's get down to execution now. All right, so execution. So at this point, we've read through the mechanicals. We've went through and we've read through our general and our materials. And now we're ready to understand our execution so we can properly estimate our labor. This is where we'll know, do we have to support a commissioning agent? Do we have to carry a laptop around for the test and balance folks? Is there some extensive owner training? What do we need to do? So let's zoom in here. All right, plans shall be examined for control devices. This is what I told you already, right? We just need to go and basically figure out our locations for sensors. We got to verify anything that we're going to wire up. We need to examine our stuff and just make sure that it, is compliant to ADA, compliant to space requirements, etc. Protection. All right. We need to make sure it's protected. This reminds me of Grand Prairie Police Station in Texas, Dallas, Texas. I think it was Grand Prairie. And they had 3 Daikin units. And I don't know who left the door open to the Daikin units, but someone did during construction. And like this crazy storm came through and blew water all over the control section. And I'm pretty sure it wasn't us who left it open, but we got blamed for it and they wanted us to pay the cost of replacing the integration cards in the Daikin units because they got rained on. And so there's a big back and forth about that because of this right here, this protection. Coordination, this just means you're going to show up at the meetings. You're going to coordinate your schedules. I've hammered this so much in our past episodes. Please show up to the initiation meetings. Please work with your electrical folks and be like, hey, we need this on. We need this working. This is our Gantt chart that shows like, hey, if you give us power on this date, it's going to take us this many days to do XYZ. All right. Test and balance. Where did that go? There it is. All right. So what do we need to do? This means we got a single set of tools. So we need to provide a laptop. We need to train them on that laptop. And, oh, there it is. Dadgummit, right there. Shall provide a technician for the duration of 8 hours to assist in the process, right? So we got to provide a laptop. It's got to have our software on it. We want to create some test and balance graphics to make their life easy. And we have to spend 4 hours training these folks. And then we have to do 8 hours of assistance. General, so account for that in your cost. General workmanship, right? This is the basic stuff. Install stuff, right? Make sure it's wired good. You know, all those things. Communication wiring, this is going to talk about all of that. You know, what do you got to do? Installation of sensors. This is basic stuff. Go through it with your electrical sub. Make sure they understand what this all means. Okay? Pretty straightforward there. Let's continue on. And let's get eventually into programming. All right, so programming here, it's going to talk about how do you need to name, how do you program, what do you do? All right, and so your programming, this is just basic stuff, right? It's pretty straightforward. User interfaces, provide graphics. I'd pay attention to this, understand what they expect, and understand, you know, right here, this section where it talks about installing, starting up, troubleshooting, operators. So this is the IT stuff, right? Making sure it all works. Here's where a lot of people lose their shirt. I told you folks, I knew this was going to go long. I'm trying to make it enjoyable. Hopefully it's great. Those of you who are listening, if you haven't picked it up by now, we're showing stuff. So go to podcast.smartbuildingsacademy.com/355 for the recording. Prior to acceptance, right, we got to do a bunch of tests. And then we've got to do some control system checkout. And we have to go and have the engineer observe this stuff. So it looks like there's some commissioning. And it looks like it has to be 2 people going through and doing this stuff. And it also looks like there is seasonal changeover, so you might have to come back halfway through the season. Then finally, talks about the different performance tests we're going to have to do. Loop response, optimal start, logs, etc. Cleaning, basic stuff. And then training. We have to provide training. What do we have to provide training on? Here it is. It needs to cover all these things. I don't normally see this in here. Normally it's kind of just hit or miss. And then it's SOP. What is our SOP? Does our SOP match our mechanical drawings? And there you have it, folks. That is Mechanical Plans and Specifications 101. I hope you learned something. I know we went a little bit longer than the 30 minutes, but I think it was worth it. I don't think you're going to find much information like this anywhere else. So I hope you took some stuff out of this. All I ask is that you like, subscribe, and share our podcast with your peers. You know, if you're on iTunes, like us, leave us a 5-star review if you feel we've earned it. If you're on YouTube, like and subscribe. If you're on LinkedIn, please like and comment, because apparently shares are useless on LinkedIn. Thank you so much. Everything will be available at podcast.smartbuildingsacademy.com/355. Once again, that's podcast.smartbuildingsacademy.com/355. It'll be available in about an hour of the time of this recording. I'm going to see if you all have any questions. I'm going to give you a minute or two to ask whatever you want about this, and I will answer if I can. So I'm going to refresh LinkedIn, take a sip of water, and wait for questions. Helps if I unmute myself. All right. Anything coming through on YouTube? No. Anything coming through? Oh, I said if I had time, I'd talk about Div 25. Okay. Div 25. Div 25, integrated systems, right? I mean, that's what it is. Div 25 is your MSI stuff. I don't know how I feel about Div 25. To be totally straight with you, I feel like it's not the most useful way of doing MSI work. Having done a ton of MSI work, having built out a ton of MSI use cases for very complex projects, it really needs to be a conversation with stakeholders that creates use cases. And then once these use cases are created, you create statements of work, and then you go to a partner ecosystem and you build out these statements of work, and then those partners execute it. That is how I feel MSI work should be done. I believe putting it into a spec section, in my opinion, it's too constrictive for the level of calibration or collaboration that needs to happen for MSI work. There's a lot of collaboration of, who's on first base, who's on second, whose data schema takes precedent. What is the patching process? What is the network process? There's too many, in my opinion, variables to MSI work that doesn't lend for a spec environment. So that's why I tend to not go down that path. All right. Let's see if there's any more questions coming in here from folks. We do listen, so I appreciate you all going on YouTube and LinkedIn and being like, hey, we'd like to learn about this. Hey, we'd like to learn about that. If we're not experts on a topic, I mean, we've got a crazy huge audience, so I could make a couple messages and get pretty much any expert on the show. It's not terribly difficult. We're the most listened to podcast in our industry. So if there's a topic you all want covered, by all means, let us know. I'm going to see if anything else comes in. I'm not seeing it. So yeah, with that, we'll call it. Thanks so much for being here. I really appreciate it. I hope you all enjoyed it and found this valuable. Like I said, podcast the Smart Buildings Academy /355. And if you do us a favor, like us and subscribe on YouTube, leave a comment and like on LinkedIn. And if you're on iTunes, please go and like and leave a 5-star review. That helps a ton. And it's a small ask, I feel, for the level of content we give out. Thank you so much. And I hope you all have an amazing day.